series of lectures on expected questions in GATE. Today I am taking questions on refrigeration and air conditioning, that is RAC. So thank you all for the overwhelming response to the earlier two videos, which were on thermodynamics. And now I am taking questions on refrigeration and air conditioning. So here are some of the questions which I wish to discuss with you. Now let us read the first question. In heating and humidification process, dry air with relative humidity, okay, 0.1, and ambient temperature, okay, 10 degree, is mixed with superheated steam, okay. The resultant mixture is, the final condition is this, and the relative humidity of the mixture is this. The total pressure is 102 kilopascal, of course. The saturated pressure of vapor at 10 degrees centigrade and 25 are given. Now he is asking, what is the quantity of steam added in gram? Chalo, let's do this. There is air of course at state 1, and he has given the relative humidity at state 1. How much is that? 0.1. Okay, and the temperature is given as 10 degrees centigrade. Now it is mixed with superheated steam. Here we have steam and its temperature is T, and let it come out at so isko hum 2 le lenge, let's take it as 2, and let the resultant be 3. Okay, see the process, heating and humidification process. Now at 3, dekho, the resultant mixture has a temperature of 25 degrees centigrade and the relative humidity is given as 50%, that is 0.5. Now the question asked is how much. So this is the actual process, my dear students. Initially the air is at 1, okay, and the temperature is given as, this temperature is given as 10, and on this axis we have dry bulb temperature, and on this axis we have omega, that is specific humidity. Okay, it is heating and humidification, so the temperature is increasing, heating, omega is increasing, so humidification. This is my final state, which is 3. So this is my final state 3, and the final temperature is given as 25 degrees centigrade, and the relative humidity is given. Okay, no problem at all. So here the relative humidity is given and here the relative humidity is given. Now what is the question? How much steam is added for 1 kg of dry air? Let the specific humidity at 1 be omega 1, let the specific humidity at 2 be omega 2. Okay, no problem at all. Now the question that is asked is how much steam is added, means it is not about how much moisture is added. Don't do anything, just calculate omega 2 minus omega 1. So there is addition of moisture, that is steam is added, and thereby my specific humidity is increasing from omega 1 to omega 3. This is omega 3. So just calculate omega 3 minus omega 1, the problem is solved. Now how do I calculate, my dear students? 1 second please. Now I think the relative humidity at 1 is given as 0.1, and you know that relative humidity is given by PV by PVS, where PV is partial pressure of vapor, PVS is partial pressure of vapor under saturation conditions. If you have any problem, I have made good videos, like good lectures on psychrometry. Go to Unacademy and refer my code, that is PK006. There you will be seeing series of lectures on psychrometry, and there you can see all basics available, where I discuss psychrometric terms, like how this chart is developed. All those I had discussed very clearly. Chalo. Now, so the relative humidity is given as 0.1, PV1, PVS1. 1 है तो 1 लिखेंगे. So look at what is the temperature at 1. The temperature at 1 is 10 degrees centigrade. So at 10 degrees centigrade, देखो, the saturation pressure at 10 and 25, at 10 it is 1.2281. So it is 1.2281. See the unit. See the unit, and that is in kilopascal. So PVS1. Sorry, like 1 second, please. Yeah. 1 second, please. Now I'll take this. Chalo. Phi 1 is equal to PV1 by PVS1. So at point 1, the relative humidity is 0.1. I do not know the partial pressure vapor, but please look at the saturation pressure at 10 degree is 1.22, and at 25 degree it is this much. So initially I am calculating at 1. So don't worry at all. So now I'll write PV1 by PVS1. 1 is at 10 degrees centigrade, so it is 1.2281. So I will get the value of PV1. So if I do that, and I am getting it as 0.122, yes, ये तो direct है, 0.12281 kilopascal. Excellent. Now I think I can calculate omega. Already I have derived in my earlier classes. Omega is 0.622 PV by P total minus PV. Have a look at this. PV is partial pressure, and if it is omega 1, this will be PV1, and P total is constant. What is the total pressure? It is, where is that? 102 kilopascal. If PV is in kilopascal, P total is also in kilopascal. So let me calculate omega 1, which is 0.622 PV1. Just now you have calculated, that is 0.12281 divided by P total. What is P total? 102 minus, okay, where is that? PV. What is PV? 0.12281. So everything is known except omega 1. And from this I get omega 1 as 7.498 into 10 ki power minus 4, so many kg of vapor per kg of dry air. What does it mean? This is the value of mass of vapor in 1 kg of dry air. That is my omega 1. Excellent. Now observe. Let us calculate omega 3. What is omega 3? Final state of the mixture, which is at what temperature? 25 degrees centigrade. And what is this 3 point PVS? Okay, so I know omega 1. Now we'll go to, my dear students, now we'll go to this next question, that is the next part. So let me erase all this. So just remember omega 1. What is omega 1? 7.48. Okay, now have a look at this. Let me write. Similarly, I'll calculate phi 2 is equal to PV2 by, or rather I would say phi 3. PV3 by PVS3. Please note down that 1 is at 10 degrees centigrade, 2 is at T, and 3 is the final, which is at 25 degrees centigrade. So from here my air is absorbing, and finally it is reaching omega 3. Chalo. Now phi 3, what is the final relative humidity? The final relative humidity is nothing but, the final relative humidity is 0.5. So therefore 0.5 is equal to PV3 by PVS3. So at 25 degrees centigrade, what is the saturation temperature? 3.1698. From here I can calculate PV3. If I calculate that PV3, I am getting this as 1.5849 kilopascal. Excellent. This is PV3. Now rest is very simple. Omega 3. What is omega 3? 0.622 PV3 by P total minus PV3. All these equations I have given in my earlier classes. So omega 3 will be equal to 0.622 PV3. What is PV3? 1.5849 by total pressure is how much? 102 minus 1.5849. So यहाँ से I can calculate omega 3, and that omega 3 turns out to be 9.817 into 10 ki power minus 3. So many kg vapor per kg of dry air. And this is my omega 3. Now what is he asking? What is the moisture added? So very simple, my dear students. देखो एक बार. This is my state. This is my psychrometric chart. So therefore, this is the initial value of omega 1. and this is the final value of omega, that is exiting omega 3. And omega 1 is, we have already calculated. How much is that? 7.498 into 10 raised to minus 4. And this omega 3 is 9.817 into 10 to the power minus 3. All these are in kg vapor for 1 kg of dry air. Now tell me, how much is the increase in moisture? From 1 to 3, it will be omega 3 minus omega 1. But all are for 1 kg of dry air. He is also asking for 1 kg of dry air. So therefore, steam or moisture added will be equal to omega 3 minus omega 1, which is 9.817 into 10 raised to minus 3 minus 7.498 into 10 power minus 4, and this is turning out to be 9.667 into 10 power minus 3 kg of vapor per kg of dry air. What does 10 power minus 3 kg mean? Because if you see, my dear students, he is asking in gram. It is asking in gram. So therefore, this can be written as 9.667. 10 power minus 3 kg is gram. So many gram of vapor or steam is added for 1 kg of dry air. So your fill in the blank should be, your answer should be, in this, the answer should be 9.66, something like this, 9.667 gram of vapor per kg of dry air. This is a very good question. Okay, chalo. Now we'll move to the next question. This is a very good question. I don't say very tough, but most expected question. Now we'll move to the next one. This is easy. Chalo. Now, shall we do this? Or this ye acha hai ya ye acha hai? Anything we can. No problem at all. No problem at all. Dekho. This is also a good question. Let me do this. Moist. This word is very important. No moisture is added or removed. Means omega is equal to mv by ma. No moisture is added or removed. Anyway, dry air mass is constant, which is a fixed part. The only variable is what? Mass of vapor. So in this problem, moisture means vapor is neither added nor removed. So therefore, this omega is constant. And moreover, it is, what did he say? It is heated. It is nothing but heating at constant omega. Why omega is constant? Because he only said, I'll read out the question. Moisture enters the duct at, okay, and there is a duct, okay, and say this is the heater. Air is entering at 1, okay, and at what rate it is entering? 3 kg. Actually, when nothing is given, it means it is kg of dry air per second. At what temperature it is entering? 10 degrees centigrade. And what is the relative humidity given? 0.8. Okay. And it is exiting at, leaving at 30 degrees centigrade. No moisture is added. And the pressure is constant throughout. That is, the total atmospheric pressure is 1 bar, which is constant throughout. The saturation pressure at 10 degree, this is 10 degree. So I will write it as PVS1 because 10 degree is taken as 1. The saturation pressure at 10 degree is how much, my dear students? 0.0 is 0.01228. Of course, it is in bar. Okay, no problem at all. Now, what we do is, what is the, okay, here's given. What is the amount of heat added? Excellent, my dear students. Let this be 1, let this be 2, air is entering at 1, air is leaving at 2. Now you apply steady flow energy equation. So what is that? H1 plus C1 square by 2 plus Z1 G plus Q is equal to, I am applying steadily, air is flowing, it is picking up heat. My air is picking up heat, that's why it is heated from 10 degrees centigrade to 30 degrees centigrade is equal to H2 plus C2 square by 2 plus Z2 G plus W. It is just a heating coil, no work transfer. And when nothing is mentioned, kinetic potential changes are neglected. Therefore, Q amount of heat added is equal to H2 minus H1. Calculate the enthalpy at 2, calculate the enthalpy at 1, and difference in enthalpy will give you what? Amount of heat. But that will give me per kg of dry air. All these are calculated per kg of dry air. and if I multiply with mass, how much is that? 3, and that you will get the total heat. So let me do this. So the main aim here is to calculate enthalpy at 1, enthalpy at 2. Okay, now let me erase this. Chalo. Now let us calculate enthalpy at 1. State 1. 1 is at 10 degrees centigrade. The relative humidity is 0.8. Okay, now dekho ek baar. He has given, and you know that enthalpy is an extensive property. Total enthalpy of moist air is enthalpy of dry air plus enthalpy of vapor. Total enthalpy of moist air is enthalpy of dry air and enthalpy of देखो एक बार, if I want the total enthalpy, it will be enthalpy of dry air plus enthalpy of vapor, and small h specific enthalpy is total enthalpy per unit mass. Excellent. So this can be written as, my dear students, what is h? Total enthalpy. It is h is equal to m into h. So HA will be equal to MAHA. HV will be equal to MVHV. All these I had explained in my earlier classes. So in air conditioning, all calculations are based on 1 kg of dry air. So divide both sides with mass of dry air. Divide both sides. So this I write as smallish. Please note on that it is the total enthalpy of moist air. Dekho, H is HA plus HV. Total enthalpy of moist air, but it is expressed for 1 kg of dry air. That's why I write it as kilojoule per kg of dry air. Don't get confused. It's not the enthalpy of dry air. It is the total enthalpy of moist air, but expressed for 1 kg dry air. And that will be equal to, divide karo isko, HA plus divide karo MV by MA. But what is MV by MA? Omega HV. Always remember the total enthalpy is given by enthalpy of dry air plus omega times enthalpy of vapor. So here dekhna. The enthalpy of dry air is given at inlet and outlet, and the enthalpy of vapor is given. But if you want the total enthalpy, dekho, at the inlet, enthalpy of dry air, dekho, enthalpy of dry air at inlet is 283.1. At the inlet, dekho, and the corresponding enthalpy values are enthalpy of vapor 2519.8. Please note down 2519.8. एक सेकंड प्लीज. Right. Now, 1 second please. चलिए. Yeah. 2519.8. Very good. So I want the enthalpy at 1. It will be HA plus omega. But I need omega. How do I calculate omega? Very simple, my dear students. How do I calculate omega? Omega is equal to 0.622 PV by P total minus PV. Awesome. And the total pressure is constant. So, and the relative humidity at 1 is given. How much is that? 80%. And the saturation pressure is given. Dekho, the saturation pressure at 10 degree. 10 degree is given as 0.0. देखो, I'll calculate the value of phi is equal to, my dear students, तो इसको थोड़ा रब करेंगे हम, कोई दिक्कत नहीं. I'll erase this. Now, right. So now we'll move to this. Eraser. Is wrong. Okay. देखो, phi 1 is equal to PV1 by PVS1. What is phi 1? 0.8. It is given at 1. PV1 I do not know. By saturation pressure is given at 10 degree. How much is that? 0.01228. From here I can calculate PV1. So from here I can calculate PV1. Take a second now. Okay. Now I'll calculate PV1. देखो, PV1 is equal to 5 into PVS1 because 5 is PV1. So PV1 it is 0.8 and that is given as, how much is that given? एक second, point कितना दिया है? 0.01228. So you will get PV1 as 9.824 into 10 power minus 3. Very good. So omega 1 is equal to 0.622 PV1 by P total minus PV1. So omega 1 is equal to 0.622. PV1 is 9.824 into 10 power minus 3, but these are in bar because that is given in bar. So P total should also be in bar. And how much is that P total, my dear students? 1 minus 9.824 into 10 power minus 3. So from here you can calculate omega 1. If I calculate, I'll get this as 6.116 into 10 power minus 3. Excellent. But please note down the process. It is something like this. Why it is something like this? Clearly he said moisture is neither added nor removed, so omega will be constant. So this is my enthalpy 1 and this is my enthalpy 2. Total heat added will be equal to H2 minus H1. How do I calculate H1? Very good. HA plus omega 1 HB. Just now I gave this equation. Similarly, he has given in the problem HA HV at inlet and outlet, and that will be equal to, he has given those values. HA is equal to 283.1 plus omega is given as 6 point, just now we calculated, into 10 power minus 3 into HV and 2519.8. And एक बार check करेंगे, we'll see at the inlet 283 and 2519.8. Excellent, my dear students. Excellent. And if I calculate, I'll get the value of H1 as H1 value is equal to it will be 296.7. On similar grounds, I can calculate H2. How do I calculate H2? HA plus omega 2 into HV. My dear students, omega 1 and omega 2 are same. No need to calculate omega 2 because moisture is neither added nor removed. So omega is same. And omega is same. Already HA is given at the outlet. How much is HA? 296.7 plus omega is already known, 6.11 into 10 power minus 3 into HV is given. How much is HV? At the second case, 2556.3. And if I calculate this, I'll get the value of H2, and that H2 is coming out to be 316.98. And you know H1, H2. Now what we do is, my dear students, you know H1 and H2. So therefore, now simply heat transfer is equal to, or heat supplied is equal to H2 minus H1. But you know you have to multiply with mass. How much is that mass given? I think 3. So therefore we can write clearly this is Q is equal to M is 3. What is the unit of M? Kg dry air per second. H2 is 316.98 and H1 is 296.7. This is kilojoule per kg of dry air. So kg dry is gone. Kilojoule per second is kilowatt, and this turns out to be 60.8 kilowatt. This much heat is supplied. And this is, my dear students, a very, very good question. And I'll be coming up with many, many more lovely conceptual questions. And please keep watching. So thank you for watching. So I'll come with more such questions. Okay, thank you.